Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 60 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we'll be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I'm going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you 2 lessons ago. I think it was lesson number 58. And that was to build a little barometric pressure weather station that would not just show the present barometric pressure, but would show a little graph of the barometric pressure over the last 24 hours. So I must start by asking, how many of you were successful? If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair, but never fear. I am going to show you my solution today. Now, I already have my solution running, so I can kind of show you what the objective of this lesson is. And so without further ado, I will get out of your way. I will have one more little sip of coffee. And then we'll jump over and show you what we're going to be working towards today. Okay, this is the GA87 module, which is in your Sunfounder kit. Really what we're using on that module is the BMP 180 pressure sensor. So if you don't have this module and you just have the BMP 180 pressure sensor, you should be able to go through this lesson and do it no problem at all. But you can see what we are doing is we also have the most excellent SSD1306 OLED display. And then I showed you last week how you can plot any graph at any place on any OLED with this little function that we developed in the last lesson. So we sort of like in lesson 58, I showed you how to get the pressure sensor up and running and reading pressure like the weatherman does, where the pressure is in inches of mercury and is normalized to sea level. So we got all that taken care of in lesson 58. In lesson 59, I showed you how you could build these little graphs anywhere on your OLED. And so now we're ready to bring it all together where we are sitting and instantaneously measuring barometric pressure, normalizing it to sea level, and then showing a little graph of, the barometric pressure over the last 24 hours. Now, I have to show you here, I have this horizontal line. That horizontal line is the normal expected barometric pressure, which is 29.92. And what do we know about weather? If we are having a barometric pressure dropping, and it is both dropping and going below 29.92, we expect inclement weather. We expect storms and disturbances and winds and inclement weather, okay? But if the barometric pressure is growing above 29.92 over time, we are expecting clear weather. Okay, so I got this little program running yesterday, and so I have not been running it 24 hours, but probably about 20 hours. And this one little line here, that's just when you turn it on. You don't have a reading, so you're reading 0, and then you get your first reading and it pops up. But then over time, I am measuring the the barometric pressure, and the most recent data is here, and the oldest data is here. Now, I have this set where it's updating every 10 minutes. How did I get 10 minutes? Well, if you take the number of minutes in a day, and we can display 128 data points on the screen. You take the number of minutes in a day, you divide by 128, and you come up with something like about 10 minutes. And so if I update the graph every 10 minutes, then I will have 24 hours of data. Now, what is my barometric pressure doing? It is increasing, and it is really increasing. It's above the 29.92, and it is at 30.17 and continuing to increase. So what do we expect? We expect very, very fair weather. Now, this morning when I woke up and I looked outside, it was completely foggy. I couldn't see anything because of this dense fog. So if I had just been sitting here, I would thought, man, we're going to get rain today. Look at this heavy fog. We're going to get, we're going to get a rain or a storm. But as the looked at the barometric pressure and I saw that it was increasing. So I said, no, we're going to have a fair and clearing day. And you can see that in the last hour or so, the fog is burning off. We have a very clear day. We have a very fair day. And I would imagine, based on my pressure, in another hour or two, we're going to have some bright sunshine, and the little wind that we have is probably going to completely die down. So these little devices are pretty interesting. And so let's jump in and let's see if we can get this thing going, okay? First thing I need you to do, I need you guys to kind of catch up with where I am. I need you guys to kind of catch up with where I am. And let's see here. Okay, so I will need you to go to the most excellent www.toptechboy.com, and I need you to use this happy little search tool and search on something like Arduino Weather Barometer. This was the work that we did in lesson number 58. Now, this schematic shows you how to hook the circuit up. You can see that we've got the power boiling. You probably already have your circuit built, but you guys that are drive-by shooters and aren't taking the class and just ended up at this lesson, understand that if I go too fast, you get a little confused, go back and watch the last lesson, 59 or 58, and probably any question that you have will be answered there. Now, in addition to the schematic here on that page, we also have the code that we developed in order to get the barometric pressure, reading pressure, and showing pressure on the OLED screen. So it was just showing in real time what the pressure was doing. And then the new thing we're doing today is we are adding that little graph, okay? Hopefully that makes sense. So you grabbed your code there. Now let's go over and let's get ourselves a fresh new Arduino IDE with bare minimum, and we are going to paste it. Okay, and so now what does this do? This just goes in and it makes barometric pressure readings, and then it displays them on the screen. Okay, so let me go ahead and run this, and then we're going to see if it is happy, just to make sure that we can copy and paste. All right, just to make sure that we can copy and paste. And verify our circuit's working, verify that I didn't have any problems in getting that code up onto the website. Okay, it's looking pretty good. All right, and now we are downloading, and it looks like we made it with no errors. So I'm going to come back over here, and you can see that I'd turned the power module off, and I was running just from the USB. So now I will unplug the USB, and then I will turn this thing on, and then boom, look at that. Now you see this number's kind of changing quickly because that was the low pass filter. That was the low pass filter kind of spinning up. But then once it spins up, it's stabilized at 30.16 inches of mercury. That looks good. And remember, on our little 24-hour graph, we had gotten up to 30.17. So that's a high pressure. Again, what we're expecting is we're expecting to see clearing weather today. And all of this this looks good and it looks like it is working. And so I think that is just really good. Let's just very briefly look at this code and just kind of show what we're doing, that you've got to install your libraries. Now, if you guys have been taking the class, you've got the libraries, but if you don't, you need to install the Adafruit GFX library, the Adafruit SSD1306 library, the Adafruit BMP 085 library, which is the one that allows us to use the BMP 180 pressure sensor. Then what we do is we kind of set up our barometric pressure, we set up our screen, and then down here is where all the action happens. This we are making an instantaneous barometric pressure measurement. And then we take that raw barometric pressure and we run it through a low pass filter to get barometric pressure, bar press, and that is the low pass filter data, which takes all the short-term noise out and gives you a nice smooth number like what you see here. Okay, you see that's not bouncing around because it has gone through the low pass filter. Okay, we'll come back over here. Maybe I can watch this view. Maybe we can work from this view. Okay, now what we do is we clear the screen and then we put the barometric pressure on there and we put it in inches of Hg. Now the next thing we're going to need to do is, what do we have to do? Now we have to take this number and we have to graph it across the bottom of the screen. We're going to have to take this number and then we're going to have to graph it over the bottom of the screen for 24 hours. So we need to make a little bit more room. So what I want to do is this 30.16, that is right here. Remember, we're in our void loop. And first thing is, I said come down to the 12th pixel. I can't afford to waste 12 pixels on blank space, so we're going to make that a 0. I love the font 3 size, but I can't afford it. I'm going to go to 2. Okay, and now instead of a print ln, which puts 30.16 and then inches of Hg, I want that on the same line because I want as much of this space as possible to be used for our graph. So I'm not going to make that a print ln, I'm going to make that a print. And then now I'm going to take this and I've got to make my label smaller if it's going to fit on there. So yes, the number is going to be large, a font size 2, but then the label is going to be a font size 1. Now what I hope happens here is I hope this all fits on the top row and that you can read it. All right, so I'm going to turn the power module off because we don't want the power module and the USB plugged in at the same time. So I will plug the USB in. Now I'm going to download this code and then we'll go back over there and see if it's working. Looking good, looking good. Downloading. Okay, it is downloaded. So now unplug the USB, turn your power module on, and shazam, look at that. We spin back up to 30.16 inches Hg. It's readable. You can see that I really need a space here, so I'm going to scoot that inches Hg over so it's not just right up against that. And I've got a good 80% of the screen left down here for the live chart. Okay, the chart, the continuously updating chart of weather over the last 24 hours. And so now we are ready to go to that part of the problem. So what we're going to do is we're going to go back to www.toptechboy.com. Let's see if I can pop that up real quick here. Yep, there it is. Now what we're going to do is we're going to search now on, we're going to go to a different lesson. You're going to search on last week's lesson, which was plot any data or graph on any OLED display. So you want to search on that. You'll come to this lesson, and then you can see that you're going to get this code. Now, what do we need to do? This OLED goes from 0, 0, the 0th X value and the 0th Y value. That's pixel 0, 0 down to pixel 127.63. Now my data doesn't come between those numbers, so I have to take the raw data that I'm measuring and I have to plot it onto this screen, and not just onto the whole screen, but onto the section of the screen that is available. So that is what I did last week. I showed you how to take your raw data and then normalize it so that it would plot on your screen where you wanted it. Now, in order to do that, what you're going to need is you are going to need these two functions. You're going to need norm data, which takes your raw data and normalizes it into the data that will show up properly on the screen, and then void plot graph. And what plot graph is, it takes your normalized X array and your normalized Y array, and it makes a graph in the proper part of that screen. So let's get this. We're going to get this and we are going to copy it. We're going to come back over to our program if we can find it. I sure hope this is it. Okay, now I'm going to come here, and you can see that this was where I normalized pressure, right? We had to, I guess the other thing that I should say that we do up here in the old program is the barometric pressure. Now, what we do is we get the normalized pressure, and that is like if I read my barometric pressure here, it looks low because I'm at a high altitude. The weatherman, he normalizes everything to sea level. So my raw reading of barometric pressure is going to look low compared to the weatherman. So what do? I do what he did, which was normalize it back to sea level. So this norm press here, that is this function that takes a measurement of barometric pressure, and then that's in pascals, and it converts it to inches of mercury, and then it normalizes it back to sea level. If you want to understand it better, go back and watch lesson number 58. But anyway, we're going to come below that, and we are going to add our two other little helper programs. Okay, now we're going to come back and we're going to snag some more little code goodness. And what this is doing, this is just going to remind me that after I get my data, I'm going to need to normalize it and plot it and then show it. So I'm going to go ahead and get that as well. And then we'll come back to our program. Okay, we're going to come back to our program. And now I'm going to come down to the bottom of my void loop. Okay, and so after I show that nice business there, I'm just going to come down and remind myself that I'm going to need to normalize my data. I'm going to need to plot my graph, and I'm going to need to display it. So let me just make sure and think a little bit of a second here. Yeah, so the last thing I'm going to want to do is normalize my data, and then I'm going to want to display it. Normalize, plot, and then display. I think that's most excellent. Okay, so all that is looking good. Now there's also some parameters over there in that program that we are going to need. So let's come back over here and get those. And so if you look, this is importing the libraries. We've already done that. Now, what is all of this business? The raw X data and the raw Y data, that's the data that you are measuring from your BMP 180. That is your raw data. And we're keeping it over time. We're keeping an array so that we can plot the data over the last 24 hours. So this is the raw X, and then we normalize the X. Then we have the raw Y, and we normalize it, right? What is the normalization? It's taking that and making it where it will fit on the screen. That's what normalization does. Now, so that is what that stuff does. Now, the X min is an X max. That is your data. If you look at your X data, what is the minimum value of X and what is the maximum value of X? And your normalized data, what is the minimum, or your raw data, what is the minimum Y and the maximum Y? So for your raw data, what is its domain in X and what is its range in Y. Okay, so you're going to need that. Then what the PT, PB, PL, PR, that defines where on the screen you want your data plotted. You want to plot it from the top pixel, PT, to the bottom pixel, PB. Now you see in this program I had PT set to 0, which means it would be all the way up in the top corner. But I'm going to have to change that to a PT down below. So PT, PB, this is PL, P left, and PR, pixel right. Okay, so we're just going to get all of this stuff because that is going to kind of help us get going. Okay, so you see what all I've gotten? I've gotten from the raw X down to the number of points. Okay, now let's get that. Let's come back to our program, and that goes up here at the top. Okay, so we're just going to put this in like this. Now we got to go in and we got to think about all those values that I just pasted in. We got to think about all those values that I just pasted in. Okay, why am I saying everything has 128 points? Because this display is 128 pixels wide, so I can't display more than 128 data points. So I'm going to normalize all of these arrays to 128. Raw X data, that is just, my raw data, the X values, and then raw data Y is raw data, my Y values. It's my raw pressure data. Okay, so those are my arrays. Now, what should my X-min be? My X-min should be 0 because I want to start at 0. Now, on my X-axis, I'm not going to try to save the real time of day. I'm just going to have an arbitrary X-axis that goes from 0 to 127, and 127 is going to be the most recent data point, and 0, an X value of 0 is going to be the oldest data point, and then the graph is going to be moving this way with time, with this always being my oldest reading and this always being my newest reading. So for that case, the minimum X value would be pixel 0, and the maximum X value would be pixel 127. Now, why 127 instead of 128? I have 128 pixels. I'm starting counting at 0, and so then I will end up at 127. Now, minimum and maximum. Okay, now it was -1 and 1 because on that code I was plotting a sine wave. Now I'm going to be plotting barometric pressure. Now, practically, the minimum barometric pressure you're ever going to run into when it's normalized for sea level would be 28 inches of mercury. And that would be like a really violent storm coming in. And the highest you're ever going to see is 31. That would be like a high pressure system, like a really high pressure system that's like locking the rain out and locking the clouds out, and you're going to be stuck there with sort of very fair weather, but no chance of rain, if that makes sense. All right, now where do I want to plot this? What is the top pixel? Well, I don't want to go to 0 because it would overwrite this. And so if I make this top pixel about 14, it'll start it right about there, 14. And then 63 is my bottom pixel. That's good. And then we're going to go 0 to 127. That's going to be good. Okay. Now, we don't need pi in this, so I'm going to take that out. Okay. Now, how many points do I have? I have 128 points. It starts at pixel 0 and it goes to pixel 127. Hopefully you're comfortable with that. So now this code that I already have, it sort of sets up my barometric pressure. Okay. It sets all that up. Now, very, very important. Remember I said that when I read my barometric pressure here, when I just read it, I'm not reading 30.16. I might be reading something like 27. Okay, why? Because I am at an altitude of 1,127 meters. Okay, what does the weatherman do? He normalizes everything down to sea level. So we have to normalize everything down to sea level. And we do this down here with our norm press, our normalized pressure. And we put in a bunch of physical constants. Then we read the barometric pressure. It's in pascals. Then we convert it to inches of mercury. And then that barometric pressure in inches of mercury, we have to normalize it back to sea level. But to do that, we have to put in our elevation, which, how do I get elevation? I pass it as ALT. So in the call up here, in the call, what do I pass it? ALT. What is my ALT? 1127 meters. If you want this to work, you have to put in your particular elevation in meters. You can look it up on Wikipedia, or if you want a more precise reading, what you can do is go to Google Earth and then hover the cursor over your exact location, look in the bottom right, and it will show you the elevation, and then make sure that you convert that to meters. Okay? So that looks good. Now we're setting up the screen. All of that is good. Okay. Now I think the next thing that we need to do is we need to go ahead and set up our raw X data array, and it's always just going to be 0 to 127 because it is an arbitrary X scale, but we need to set that up. We need to set that up over here in our void setup. So we're going to come to void setup. We're going to come down to the bottom of it, and then I'm just going to build that X array. So I'm going to say 4, and then I'm going to go int I is going to start at 0, and then I is going to go until num points less than num points. That means that it will stop one before num points, which will be 127. So that will be good. And every time through, we're going to increment I is equal to I plus 1, like that. Okay, so I've got my for loop, open my for loop. Okay, now what are we going to do in there? Well, we're going to build our raw X data, like that. I like that. And then what is that going to be equal to? That is just going to be equal to I like that. I think I want to run this thing. Just to make sure I haven't put any errors in there. So we turn the power off. We plug this in. And really, we're just looking to see if it compiles more than anything else. See if we got any mess that we created in our copying and pasting. Okay, that looks pretty good. It's downloading. All right. Okay, so it compiled and downloaded. I am going to unplug, and then I'm going to turn it on. And then what I see is this is going to ramp up to 30.16, which we've been kind of sitting at. And you see that we've got this. Now this, okay, something popped in here. You can see that I'm getting a coordinate axis down here all of a sudden. Why am I getting a coordinate axis? Because I went ahead and said, normalize your data, plot your data, and then display it. And so what it's doing is down here in my void plot graph, it is building in there. What it is doing is it's building a coordinate axis, even though I don't have any data to put on it. And because I haven't really gone in and gotten things working, it's kind of blinking, but really that's what we're expecting. And you can see that the coordinate axis goes right up to the bottom of the data. So actually that is pretty okay. It scared me, kind of alarmed me there for a second when I first saw that. Okay, now let's see what else we need to do. Okay, a couple of things that I want to do down here in plot graph. Okay, before I do too much else, down in my plot graph. Okay, so you see what I'm doing here is I am building this is going to from left top to left bottom. This is building my vertical axis, my vertical Cartesian axis. This is building my horizontal Cartesian axis. Now I want to put another axis right at the pressure 29.92 inches of mercury, because that is your nominal barometric pressure. If you're above that and increasing, you expect clear, clearing, and fair weather. If you're there and below and dropping, then you're expecting inclement weather. So I want that reference line on there. Well, if I'm going to do that, I've got to calculate that, okay? And so that is int, and that is going to kind of be my mid value. That mid, what you expect is your nominal barometric pressure. And you might just think, well, let's just put in 29.92. That would be fine, but to plot it, I have to what? I have to normalize it. So this is a y value, and I need to normalize that y value. And the easiest way to do that is to come up here to this norm y. Let me get off of that. I hope you guys have been seeing what I've been doing. But to get off of that, to get it right, what I need to do is this takes a raw y value and it normalizes it to put it on the screen. So I'm just going to steal that because it's easier than putting it in again. And then what I'm going to do is I'm going to paste it here. Okay. Now, instead of raw data, what is it that I want to convert? I'm just going to convert the 29.92 like that. Okay. Now, that is going to create the value that I want. Now I've got to plot it. So I'm going to do an OLED dot draw line. And then where am I going to put it? From the left pixel, PL. And then what is the Y value? Mid. And then I want to go to what? The P right pixel, the right pixel. Again, mid again. And then we got to give it the old white like that. Okay. Now, let's see what we need to do here. I want to kind of see. So I'm going to have normalize your data, plot your graph, do your OLED display. And then after that, let me just do a delay of, let's say, 0.1, something like that. Okay, I'm still not exactly sure why that is blinking, but now let's come back over here. And what I want to see is now if I have my axis set up where I've got that marker line. Okay, should have turned that off first. Oopsie, my bad. Okay, so let's download this. Okay, it is going. Okay, looking good. I will unplug it. I will turn it back on. Okay, so I've got this. I've got my axis, and then I've got that reference line, which is the normal. Okay, now what I am not sure about is I am not sure why I'm getting that blinking, that it is going so fast that that thing is blinking. So we're going to have to figure out, somehow I'm not managing this real well. OLED clear display. That's good. So I'm going to clear the display. Okay, I think it's going to slow down when I put some other things in there, and it will look more proper. Okay, so we're just going to keep in mind, that we've got to, what we're doing is we're clearing, displaying too quickly, and we will fix that as we go. So we do a clear display, and then we do a display. And so let's come back over here. What I do is I do a clear display, and then I do an OLED display. Okay, I think maybe, you see I did two in all my copying and pasting. You see I do an OLED display and then I do another OLED display. So I think I need to take out that OLED display. Okay, I'm not going to run it again. I'm going to move on. Okay, and we'll just keep in mind we got to deal with that blinking business. Okay, so now here we have an OLED clear display. We reset those things so this part works good. Now we're going to come back up to the top of the void loop. Okay, so what do? We measure the barometric pressure and we measure the normalized barometric pressure for altitude with our function down there. Then we take that normalized barometric pressure and we run it through a low-pass filter so we get nice, smooth data. Okay? So now I think what I need to do is what we've got to do is we've got to build our Y data over time. Okay, over time I have to build that Y-axis data. All right, I got to build that Y-axis data over time. So how am I going to do that? How am I going to do that? I have a data point here. But what I'm going to have to figure out is I can't add every data point because the data is coming very quickly. I want to update it every what? I want to update it every 600,000 milliseconds, which would be 10 minutes. But for us to debug the code, we are going to update it. Where is that? Okay, that's something that I've got to add up here. All right, so let's go and let's add this. All right, so how often do I update it? Well, the first thing I need to do is I need to say when was the last update, and that will start with 0 because we haven't updated it. So I've got to know what the last update time is and then the time interval between updates. So I'm going to need an update interval. Okay, now so what I want to do is I want my data to be 24 hours. Okay, I want my data across the screen from here to here. I want 24 hours of data. I want this to be my most recent data point and this to be the oldest data point. And so I take like 24 hours in milliseconds. And how many milliseconds would be 10 minutes? Well, it would be 600,000 milliseconds would be 10 minutes. 60 milliseconds would be 1 minute. 60,000 milliseconds would be 1 minute. And then 6 seconds would be 6,000 milliseconds. So really what I want is if I had 600,000, now let me come back over here. Okay, if I put this at 600,000, that would be every 10 minutes it would grab a data point. But to debug this, I want to grab a data point every 6 seconds, and that way we can make sure it works, and then we'll come in and we'll change that back later. So now what do we do down here in our if statement? So I now have a data point. I want to see, do I want to save that data point? Okay, do I want to save that data point? So what I'm going to do is I'm going to do an if statement. So I'm going to say if, and then millis, that's my present time. Millis is my present time. If my present time minus my last update, if that is greater than or equal to my update interval, like that, then that is when I want all my action to happen. So what is all the action that I want to happen? If this is the case, I want to add that data point, that last data point, to the end of my array. And then I want every other data point to move one to the left. So I'm going to scoot every data point one to the left in the array, and then I'm going to add that new data point to the end, which would be data point 127. Does that make sense? So what do we know? If my present time minus my last time is greater than the update interval, then I want to pop that data point into the array. So before I pop the data point into the array, I need to scoot over every single data point to make room for it. So I'm going to say for int I, start at 0 and keep going as long as I is less than num points. So that would go to what? 127. But I want to get the next value and move to the I value. So I can't go to num points, I've got to go to num points minus 1. So I'll get to 126 and I'll take the 127 and put it here. I don't need to go again. I just go to 126, I get 127 and bring it in. So I don't go to num points, I go to num points minus 1. And then what? I is equal to I plus 1, like that. Okay, now what do I do? Well, this is pretty easy. Just my raw y data of I, okay, is going to be equal to raw y data of I plus 1. The next one is going to come into the present one. And I think that's all that I have to do there. And I'm going to do a Control T just to clean that up a little bit. So this ends the for loop, okay? And then after I end the for loop, what do I need to do? After I end the for loop, I darn well better now say this last update that I just did, the last update is now the present time, okay? Like that. So now I've got all that old data scooted over by 1, making room for the new data point. So I got to remember to put that new data point in. So what do? I say that is my raw y data, this time of what? My raw y data of num points, which is 128, minus 1, which is going to be 127, is equal to that fresh, new, normalized, and low-pass filter barometric pressure. Right? Okay. So I've got my last update. I have my data point put in. Now what do I want to do? I want to normalize my data. Okay, so I've got this Y array. I've got this beautiful Y array, but it is in barometric pressure in inches of mercury normalized to sea level. But now what do I have to do? I have to normalize it to fit on the screen where we want it to fit. So how do I do that? I am going to normalize the data to fit on the screen. So let's come over here. And so what I need to do is I need to put my semicolon. So I've normalized the data now to fit on the screen. And then after I have normalized that data, what I want to do is I want to clear OLED, clear the display like that. And then what do I want to do? I want to plot the graph like that. Okay, so at this point, I should be getting my data, and then the data should begin to show on the screen. Okay, so now I have, let's see where we are here. This opens, and let me come back over here. So this opens this big if statement. And then this opens the for loop, this closes the for loop, and then this ends my if statement. Just checking and making sure that is looking good. Okay, then I get back to my every time loop, and every time through, yes, I do want to clear the display. I want to set the cursor. I want to get things lined up, and then I want to normalize the data again. Okay, I want to plot the graph. I want to OLED display, and then I want to put a little bit of a delay in there. Now, the one thing I'm thinking is, why am I oh yeah, I'm normalizing. Yeah. Okay, so I normalize the data every time through. Okay, so that makes sense. And that's just making sure that every time I plot it, I have the latest data in normalized fashion to fit on there. So this is kind of scary, isn't it? Let's see what else I might have needed to do here. Just looking over my notes. Okay, I put the mid in there. I think this is ready to run, but man, this is scaring me because we have done a lot of crazy stuff here. So let's come over here where we can see this. And now let's see how many mistakes that we have in here. So we're going to plug that all the way in. And then we're going to come over here and we are going to download the code. And let's see how many mistakes we have. Update interval was not declared. Typo. Update interval will go to update interval. That was a typo. Okay, OLED clear display. We will need a point there. And it is running. It's looking pretty good this time, huh? Downloading. Okay, so I don't know if this is going to work or not, but what's the good news? At least it didn't crash. So now we are going to unplug this. Okay, and now we're going to come over and turn it on. And okay, let's see if we have any action happening. Okay, so I've got this, I've got that, and now I just got, after 6 seconds, I got my first data point. Okay, and then that is a most unexpected result. Okay, so we have an unexpected result, and I think I have found the mistake. So let me come back over here to the code view, and I think I messed up building my X array. Okay, so if you say I said when I built my X array up here, instead of I equal I plus 1, I said I plus equal, which is nonsense, and I'm surprised that I did not get an error there. But now let's go ahead and let's download that and see. It seems like that would have given me an error, but that could be responsible for what we just saw happen. Okay, so it is downloading. All right, and now let me come over here. Let's get where you can see this, and now what we're going to do is we're going to turn this on. Okay, I'm getting a barometric pressure reading at 6 seconds. I hope to start seeing a data point come in here. Okay, yeah, there it is. So you see you got that first data point, and it's 30.16, so it's a little bit above the line. And then you can see that I'm getting a data point coming in every 6 seconds, and that is looking good. Now, what I want to do is I want to make sure that that's going to kind of fill up the graph without any surprises. So what I'm going to do is I'm going to come over here, and instead of saying that I'm going to update every 6,000, let's just update every 600. So that's going to be almost 2 per second, just so this thing will happen faster. So let me get that downloaded. And so we're going to run. Okay, and it is downloading, and this should be running a lot faster now. Okay, so I will pull that off, and then I will come over here, and let's start this thing again. So I'm going to stop it and then start it. Okay, and now you can see that is vectored up to 13.16, which is what we would expect. And then it's coming across nice and smooth. And you see we're getting about 2 data points a second. I just want to make sure that it gets all the way to the end and kind of off the screen. You know, our first data point is off the screen to make sure that this is working. Now we see this isn't changing over the time frame, but I think at this point this should really work, if that makes sense. Okay, so let's just give it a little time, have a sip of coffee. All right, this is pretty amazing. Let me check the weather out here. Weather's looking clear. We've got some, looks like some boaters. Okay, is that some boaters? While we're waiting on our data, I'm trying to see, is that recreational boaters or is that, let's see, is that fishermen or recreational boaters? Let's see if we can take a closer look. That is fishermen. Looks like a couple of little kids, maybe with their dad, teaching them how to fish. I saw some fishermen up here too, back in the background. Okay, we'll look around a second while we're waiting for that data. Things look pretty good on the river. Okay, let's come back over here and look at this. And yes, it's gone off the screen. And now this is what we expect. This line is our nominal pressure. What did we say the nominal pressure was? Was it 29.92, I believe? Okay, so this is the 29.92. We're at 30.15 and rising, and therefore we have very clear weather, very mild weather as we would expect. And with that increasing pressure, we're going to be expecting some sunshine this afternoon. Okay, guys, I hope you are enjoying taking this class as much as I am making it. And I do need to get a homework assignment. So I think we want to go ahead and make the next step in our weather station. And what I want you to do is I want you to add that DHT11 sensor, which measures relative humidity. It's going to measure relative humidity and temperature. But remember, the BMP 180 also measures temperature. So you can get your temperature measure from your BMP 180, or you can get your temperature measurement from the DHT11. But what I want is I want you to kind of put together a little weather station. Like when you click the button, it will go to the relative humidity, showing the real value and the value over time. And then you press the button again and it shows you the temperature and the temperature over time, and then you press the button again and it will show you the barometric pressure with the barometric pressure over time. So you can just sort of cycle through your little weather station and you can get the conditions for the 3 things that you would care about: humidity, barometric pressure, and then temperature. Okay, does that sound good? And you might even, if you wanted to, you could have a 4th thing. So you could go 1, 2, 3, 4. And the 4th would be just show you the present conditions, which would be temperature, barometric pressure, and humidity. Okay, now then you would have a completely portable little weather station. Okay, so that is going to be your homework assignment for next week. And I hope I'm not overwhelming you. This is getting to be some fairly significant work that we're doing here. But you guys that are enjoying the more, in-depth lessons, I hope that you stick with me. I hope I'm not wearing you guys out as these homework assignments are getting harder and harder. Okay, guys, it's at this point that I always give a shout out to you guys that are standing with me on Patreon. These really, really in-depth lessons that I give, they don't get the 350,000 viewers, because what most people want is they want a picture of the circuit schematic. They want a little blah, blah, blah on how it works. And then they just want to cut and copy copy and paste the code. So if I took like the last eight lessons that I've done and compacted it into one 45-minute video, which just shows you the schematic and gives you the code to copy, and me just maybe pontificating a little bit of the high points of the code. It's those lessons that get the huge viewership. But the problem is, really, you don't learn very much from that. And more important to me than you guys, more important than me getting hundreds of thousands of views is I want to take someone who really wants to learn engineering, and I want to step them through it where they really learn it. But when you do that, you get like 1,000 or 2,000 views instead of hundreds of thousands of views. And so the only way I can make this material is because of you faithful people who are standing with me on Patreon. Thank you. You can also help the channel by giving it a thumbs up and leaving a comment down below. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.